Give me a minute, I just lost my okay. It's a little bit different or it's kind of interesting in the that it allows us, the extern specifier allows us to actually share variables between files. Okay. Sometimes remember we discussed the principle of modularity, that sometimes your code is so big that you have to split your code in a few text files, okay, or .c files, okay. So but still you want your files to be useful, your variables, okay, to be used by in the other files, okay. So in this case, basically what you do is that you create in your main function, you declare your variables, okay, int I, float f, main c. So this is for file1.c. This is where your main function is, and then file2 might need to use the same I, okay. This I might need to be shared with file2. So what you do here is that you use the extern keyword, okay. This tells the compiler that, okay, I have here a variable I, but it already exists, or I should go and look for it somewhere else. And this is where it go. The compiler takes care then of going through all the files and locating where I was actually defined or created. Let's put it like that, created. And the same thing for extern, okay. Extern for file3.c, okay. And in this case, we need to use float f, okay. But float f is also it's used in file1 and needs to be used also in file3, okay, right here. So we use the keyword extern, okay, as a specifier, and basically just follow with the declaration as before, float f. In this way, what happens is that the variable I and the variable f in file1 is going to be the same variable I and the same variable f, okay, in file2 and file3. So to put it in some way, okay, if you have your memory, okay, and let's say basically I, okay, let's say this is 4 bytes as we discussed before, and then you have f, right, it's 4 bytes. But basically, file1, let's just go for I. In I, okay, it's going to be referred to the same memory location in file1 and file2, okay. So they are referring to the same memory location. Same thing for float2. In file1, it's going to be referring also to in file3, the external float f is going to refer to the same memory location. This way, we are able to work with multiple files. If your program has 1 million lines of code, you can imagine it is very convenient to break up your code into smaller files than having like a huge C file with 1 million lines. Okay. Okay. So going back at actually. Once we know something about specifiers, identifiers, modifiers, specifiers, then we also actually need to look at at two ideas. Okay, one is declaration, and the other one is definition of variables. Okay. So the declaration associates an identifier with a data object, int, float, char, and its attributes. Okay. What are the attributes? Again, specifier and modifier, like short, int, static, and for a specifier, static, extern, and so forth. Okay. And the definition is exactly like a declaration, but it actually is the operation where you reserve space in memory. Okay. Yeah. So I'm hoping this is kind of confusing. Okay. These are very confusing terms. Okay. So let me show you. Let me go back to the example of extern. Okay. What is here we see we have instances of what we call a declaration and a definition. Okay. So a declaration basically has to do with actually just telling us there is an object that is of some type, okay, but it does not actually allocate the memory. Okay, let's consider between file 1 and file 2. Which of these two statements, int I or extern int I, is the one that actually creates in memory the location for I, or reserves, allocates in memory the space for variable I? It's actually the one in file 1, okay, this one. When the compiler sees int I, it actually goes to memory and reserves the location for I. Now, what about the extern int I, okay, in file 2? In that case, the only thing that is happening, this is a declaration, okay? It is just, file 2 is just declaring that there is a variable, okay, I, associated to an integer, and that is external. But it's not actually creating the allocating the memory, okay? Because if it did it, then we will have two different copies of I. Okay. So if it is confusing, this should be confusing for now, okay? And actually, this is one of the most confusing topics in C. I hope you start to appreciate why MATLAB is such a nice language, okay? Because we don't have to worry about all this mess, right? Of rules, okay? This is like all these very strict rules. Okay, that's why C is a strongly typed language with very strict rules that we have to actually follow. Okay, okay. So let's just look at the general. Now that we know about variable definition, declaration, the identifiers, and we have discussed what are valid identifiers, and actually let's now that we know basically. What is the different modifiers, like the modifiers, the specifiers? How do we form variables in C? Okay. Now let me ask you, how did we define a variable in MATLAB? Okay. So let's say MATLAB. Let's remind. So remember MATLAB. What will we do in MATLAB? Okay, we just will say x is equal to 10, and that's it, right? Y is equal to 2.75, z is equal to 8, and that was it, right? That's the way we used we created variables in MATLAB. So how do we create variables in C? Okay. Now look at C. So in general, it has to have the following components, okay? So let's consider use for one particular identifier, okay? So we have for some identifier we have to include the following, okay? And then I'll be more. Let me get another piece of paper. Okay, so sorry. Okay. So let's see. Okay, in C, we're going to need, as we discussed before, we're going to need storage class specifier. Now notice I'm using this plus, less than or equal, less than and greater than. I'll discuss what it means. It actually has